situation. The first thing you want to do is you immediately want to split your integration up here as secant squared theta secant theta. And just by definition of guys, if y'all haven't figured it out by now, that's okay. This expression to any power, right? I'm just going to put 2 for example, would still be equal to this expression. Continue. So what we have here is secant squared theta secant theta. If I break it up, which equals secant cubed theta. Now at this point, we're going to go ahead and we're going to let u equal secant theta, so that du is equal to secant theta tan theta d theta. And we're going to go ahead and we're going to let our dv be equal to secant squared theta, so that v is equal to tan theta, of course. So then upon this, we're going to plug it into our formula. Now we know by parts that we actually had this situation, right, where this integral is actually equal to our dv u here, right? Now we know that by definition, right, this is equal to dvu, which is equal to uv, evaluated on the bounds here, minus the integral of v du. So now what we're going to do in this situation, we're just going to plug in by parts here. I would highly recommend you actually do it underneath this so you don't lose track. You got secant squared theta is equal to your u secant theta times v, which is your tan theta, evaluated at any boundary here. We're just going to kind of leave it open-ended because this is an indefinite integration, so just keep this term here. And then minus your integration of v tan theta, and then du secant theta tan theta d theta. Now at this point, there really isn't a whole lot we can do just yet, so we're going to have to do by parts again. So that ends for the definition minus 1. So if I plug this in, I have secant squared theta minus 1, plugging this in for tangent here. Right, and then I'm going to have my secant theta here. This breaks this up into 2 integrations. Let's see. Secant cube theta. And at first sight, it might seem a little wary. Like you might seem a little wary from this because what have we really done? We've gotten back to secant cube theta, but this is a good thing, right? We need this to happen because we can utilize a little trick. What we can do is we can just add this to both sides and eliminate that variable in a way. Or actually, we're kind of forcing this to be the variable algebraically, respectfully. So that means we've got 2 integration secant cube theta d theta is equal to secant theta tan theta, and then of course minus the integral of secant theta d theta. Extract this, and we're just going to simply do the integral of secant theta d theta here. So to that end, and just like before in our other videos, right, we're going to let u equal secant theta plus tan theta, so that du is equal to secant theta tan theta plus secant squared theta all d theta. Guys, upon plugging this in, right, we're going to get the integral over here. Integral of plugging our d theta back in, secant theta, and then du. Now, I have a video on this if you want every single step, right? So for that, I highly suggest watching that. This is a long integration in and itself. And so the trick on the secant theta to the first power here is that you end up getting these terms canceled from factoring out the secant theta into du, and you're left with the integration. And look at this. U is equal to secant theta tan theta that we have down here in the denominator. So you get du over u, which is equal to ln of u plus c, which is just simply equal to ln secant theta plus tan theta. Let's see. We had that the integral of secant cube theta d theta was equal to, let's see, and then if we throw this back into our original expression up here, where we used algebra, and we plug in the singular secant theta that we just solved for, then we have this minus the ln of secant theta plus tan theta plus c 1/2. You can distribute if you want, but here you go. This would still be the solution.
Ninja, vanish!